Good morning, students. Today we start with the new chapter. The chapter name is the wave optics. Wave optics. So, wave optics is the branch of optics. Here we consider light as waves. That's why we are saying that the branch is wave optics. So optics is the branch. So from that branch we have classified into two sub branches. One is ray optics and one is wave optics. In the wave optics we study light as waves. So the weightage of this chapter is here also 9 marks. So the weightage of this chapter is 9 marks. From this 9 marks we get 1 for 1 marks, or we get 2 questions for 1 marks and 1 question from 2 marks and 1 question from 5 marks. Here also same. So here from 5 marks they may ask theory question, that is for long answer question or numerical problem. So one question will come for 5 marks. From this question they may ask for the long answer, that is derivation type questions, or they may ask numerical problem. From this chapter maximum time they ask the numerical problems. So we have to solve the numerical problems, means we have to know the theory of the derivations and also the important concepts that we are studying in this topic, that is wave optics. If here they may alter, that is one question for 1 marks and one question for 3 marks. So here they may alternate here. So if they ask one question in ray optics for long answer, then from this chapter they ask the numerical problem. Or in this chapter they may ask the long answer in ray optics, they ask for the numerical problem. That is alternate, either derivation from this chapter or problem from this chapter. Right? So this is about the weightage of this chapter, that is 9 marks. Next, so in this chapter, the concepts which are going to discuss is first one, Huygens principle. Huygens principle. By using this principle, we are going to study the laws of reflection and laws of refraction. Right? So the laws of reflection and refraction we also studied in the ray optics. That is, we consider their light as rays. That is, light travels in a straight line. That here, by using the Huygens principle, that is, we are going to study the laws of reflection and refraction by using light as waves. So this one is the first concept, that is Huygens principle. By using this Huygens principle, we are going to discuss the laws of reflection and laws of refraction. So next topic is phenomena of interference. So this is studied, so this concept is studied by using the principle of superposition. By using superposition principle, we are going to discuss the phenomenon of interference. So next, the phenomena of diffraction. Here we are using the principle, that is Huygens-Fresnel's principle. By using Huygens-Fresnel principle, we are discussing the phenomena of diffraction. So, what is diffraction and how it takes place? So, on the last is the phenomena of interference. Sorry, interference is overline. Phenomena of polarization. Phenomenon of polarization. Here we considering light waves as, that is the principle here is light waves as transverse electromagnetic waves. By using this principle, we are going to study the phenomena of polarization. So this is about the brief about the chapter wave optics. So first we are going to discuss the Huygens principle, then later the phenomena of interference by using the principle of superposition, then the phenomena of diffraction by using Huygens Fresnel's principle, and last is the phenomena of polarization, that is light waves as transverse electromagnetic waves. So we will study one by one. Those topics starts with the Huygens principle. Huygens principle. So first we know what the principle states. So Huygens principle. So Huygens principle. So before going to discuss the Huygens principle, first we have to know one concept, that is wave front. So what is wave front? So we already know what is wave. Actually we studied the wave concept in first year also, that is in sound. So here what is wave and what is front? That is wave front. So wave is the disturbance created in the medium. So wave is the disturbance created in the medium. That one we call as wave. So what is wave front? So what is the meaning of the wave front? So if we consider one pool with calm water, if we drop one stone into that pool, so what happens? The disturbance is created in the medium. So the disturbance created in the water, that one we call as wave. So if we consider one pool of water that is in calm, if we drop one stone to that pool, what happens? The disturbance created in the water, and that is the surface of the water starts to oscillate, that each and every point of the water starts to oscillate, and that one we call as wave. So this one we call as wave, right? So this is the wave. So what about the wave front? So if we observe this from the top of the surface at maximum disturbance, that is the particles which disturb maximum. So here that is nothing but the amplitude, right? So this one is the axis. So here we points, or we notice that at maximum distance, if we observe from the top at the maximum disturbance, so this point is at the maximum disturbance. Here we get the maximum disturbance, that is the particles oscillates on the surface at each and every point, oscillates at the surface. If we observe from the top, we find that disturbance, maximum disturbance, as circular rings, So here is the point where the disturbance created, right? So this is the point, from here the disturbance created. If we extend here that point, that is here is the point of the source from where the disturbance are created. So if we observe from the top, then at the maximum disturbances, that is at the maximum amplitude, we observe that one in the circular rings. It is in the form of circular rings, right? Like this. If we observe from the top of the surface, if we completed this one, we get circular rings like this. Right? So at the maximum disturbance, we get the circular rings. So at each and every point on the circular rings, so this one is the circular ring. At each and every point on the circular rings oscillates in phase. That is, they are oscillating in the same phase, right? They are oscillating in the same phase because from this point, each and every point are at the same distance. If the distance is x, for example, I am taking this distance is x meter, then from here also the distance is x meter. That's why at each and every points on this circular ring are oscillating in phase, right? Oscillating in phase. So that one we call as wave front. So this one we are calling as wave front. That is surface with constant surface. What's the wavefront says that the surface with constant phase, that one we call as wavefront. That is what the wavefront define is surface with constant phase. So here the particles, that is particles on the surface oscillating in the same phase. That's why these are called as wave fronts, or simply we call as the front face of the wave is called as wave front. To remember, the front face of the wave is called as wave front. So if we define means the wave front is defined as surface with constant phase. That one we call as wave fronts, right? So this is the concept of the wave front. At the maximum disturbance, if we observe from the top, or if we take the photograph from the top of the surface, these are appears to be a circular rings, and these circular rings at each and every point they oscillate in same phase. That is oscillating same phase, and these are called as wave fronts. So surface with constant phase. So this is about the wave front. So wave front depend on the source of. So wave fronts depends on what factor? So wave fronts is depends on source of light. So wave fronts depends on the source of light, right? So this one is the wave, and these are the circular parts we call as wave fronts. This is in 2 dimensions, that's why it appears as circular rings. In 3 dimensions, it appears to be the sphere. That one we call as spherical wave fronts. So in 2 dimension, if you write the wavefront means it is in circular, that is moving outwards. The speed with which the wave front travels is called the speed of wave. So next is what is speed of wave, right? So this is the source. From here the circular rings are traveling, that is the wavefronts traveling with the speed, that speed we call as speed of the wave. The speed with which the speed with which the wavefront travels is called speed of the wave. Is called speed of the wave. So the wavefront which travels at which speed? So if this wavefront is traveling with the speed v, then the speed is called as speed of the wave. Right. Next, we have the types of wavefront. For the point source, this one is the point source. For the point source, we obtain spherical wavefronts. For the point source, we obtain spherical wavefronts. So this is 2 dimension. So if we draw complete this one, it appears to be a circle in 3 dimension. It is in spherical. That's why it's called spherical wavefronts. Spherical wavefront. Because at each and every point, the particles oscillate with same in phase, that is oscillating in the in phase. That's why all the particles oscillating on this surface we get for the point source, it is spherical wave front. If we consider the point source at the larger distance, so here is the point source, from here somewhere here at the larger distance, if we consider this point source and we take this part of the sphere, so this, if we complete this one, we get one sphere. This part of the sphere appears to be plane, that is appears to be straight line. So this wavefront is called as plane wavefronts. Plane wave front, right? So for the point source at the larger distance, if we taken the part of the sphere, if we complete, we will get one sphere. We are consider only certain part from here to here. If we observe from opposite side, then it appears to be straight line. Then these wavefronts we call as plane wavefronts. So plane wavefronts when the point source is at larger distance, and we are considering the spherical wavefront. In that we are taken a part. That one we get the plane wavefront. So this is about the wavefront. So I think you understand the concept of the wavefront. That is the maximum disturbing of the particles in the wave, that is the surface with constant phase. They are oscillating with the constant phase. That one we call as wave front, or simply the shape of the wave, that is front shape of the wave is also called as wave front. So actual definition is surface with constant phase. Next, we discuss the principle of Huygens by knowing the concept of wave front. By using the wave front concept, we are going to discuss the Huygens principle. So what does the Huygens principle states? If we know the wavefront, at time t is equals to 0, that is, if we know the wavefront at time t is equals to 0, that is, if it is the source, from this source we have one wavefront, that is known wavefront, right? So this one is the known wavefront at time t is equals to 0, right? By Huygens principle. So Huygens principle helps us to find the position of this wavefront later, that is after certain time t, that is to find the position of the first, that is, we knowing this wavefront, we have to find the position of this wavefront after time t. So time t I am taking here as tau. So for this, the Huygens principle helps how to find the wavefront after certain time t. So we know one wavefront. From this wavefront, after certain time, it travels to the forward direction with the speed of the wave. After certain time t, we can find the wavefront by helping of the, that is by using the Huygens principle. Huygens principle helps us to find the wavefront after certain time t. So next, this is the concept of the Huygens principle. So what's the principle? States here. So the principle here is Huygens principle. So principle states each point of the wavefront is a source for secondary wavelengths. So each point of the wave is a source for secondary wavelength, and the wavelengths traveling with the speed of wave, and these wavelengths, each point of the wavefront is a source for the secondary wavelengths, and the wavelengths traveling with the speed of wave in all direction, in all direction. Like the wavelengths traveling with the speed of wave in all direction, in all direction. Next, so next is each point of the wavefront is the source of the secondary wavelengths, and the wavelengths traveling with the speed of wave in all direction. And that is traveling or emanating with the speed of light in all direction. These wavelengths, these wavelengths emanating, these wavelengths emanating from the wavefront, is referred as, secondary wavelengths, is referred as secondary wavelengths, and referred as secondary wavelengths. And if we draw the common tangent to all the spheres, then then we get the then we then we obtain the position of we obtain the position of wavefront after or time later time t. So this is the principle of the Huygens. So Huygens principle states that each point of the wave for the secondary wavelets and the wavelets traveling with the speed of wave in all directions. These wavelets emanating from the wavefront is referred as secondary wavelets, and if we draw the common tangent to all the spheres, then we obtain the position of the wavefront later time t. So this is the principles of the Huygens. Then here the main points are each point of the wavefront, that is each point of the wavefront acts as the source. So acts as the source for the secondary wavelets, and the wavelets traveling in all directions with the speed of light, and the secondary wavelets, that is from the source we get wavelets, that wavelets we call as secondary wavelets, and the sphere, if we draw common tangent to the spheres, then we obtain the position of wavefront later time t.